webinar. So whatever you guys will ask or question, that would be recorded and maybe published. So being said that, feel free to ask your questions maybe after the after when we done with the conference, or if you have anything, just put the comment. We will return back to you. With being said that, all over to you, Rahat.
Okay, perfect. Thank you. Thanks for organizing such a nice webinar on Saturday morning. Today, we have already taken quite a few webinars in the past, talked about deep learning, Azure, storage, AI, bot framework, all those cognitive services. But today we will talk about performance acceleration and optimization using deep learning applications for deep learning applications. So mostly it will be like a tips and tricks session for deep learning. If you are an AI developer or AI engineer or planning to start AI development, how can you guys use deep learning algorithm to do any kind of design any kind of AI application? What would be the best approach? How you're going to design your data, process your data. So I will mostly share all the like tricks that I have learned over the last few years. So yeah. Uh, and before I jump into my presentation, Deepak has already shared that I'm Rahat Yasir. I'm Microsoft MVP in AI and working at machine learning and AI engineer at Intact Financial Corp in Montreal, Canada. So yeah, it's really fun to be involved with lots of AI initiatives in this big corporation and learning a lot there as well. That's why I'm here to share all my knowledge that I have learned at my workplace. So, okay, I don't know how many people have already joined in the webinar, and I believe there will be more people who will watch this at home like later time as we are recording it. So if you guys have any question, feel free to ask me or send me any email or text me. My email is rahat.onindo@live.com. I will share it at the end. Okay. So what is the agenda for today's meeting or today's webinar? So we will cover those topics. How are we going to fight overfitting? What are the tips and tricks to design deep learning models? How can we get better generalization? um, get better performance in terms of accuracy and also runtime? How can we take deep learning applications in production and training and inferencing tips? As we all know that deep learning application needs a lot of data. It's true, and also at some extent, it's not 100% true. There are like lots of ways that you can tune your model. You can use pre-trained network that will help you to have a good result with even like with a small set of data. And also, we all know that deep learning needs lots of resources, like lots of GPUs or GPU memories. Yes, and also you can design your, if you have resource limitation, you can design your algorithm or implementation in a way where you will need less resource to get a like acceptable result. So let's talk about what kind of improvements we can make in a deep learning application. We can improve our deep learning application based on the performance of like using the data. We can improve performance. We can improve performance by algorithm tuning. We can do data pre-processing and pro-processing, and also we can do proper GPU usage. We can increase the performance using ensembles and also through algorithms as well. And different, we can also adapt different training strategies. These are the things that we will mostly talk about today. Improvements regarding data, algorithm tuning, data processing, GPU usage, ensembles, and strategy. So the first one is improve performance with data. So for any kind of deep learning applications, if I hope you guys are familiar with deep learning, the algorithm and the application. As this is like maybe third episode of the series that we are taking from last 1 year. So today I'm just sharing about the tips and tricks. So what can you do to improve the performance? You can using data. First thing that, as I have already said, you need more data. So how can you get more data? So there are like lots of ways. One thing is like you can use lots of open source data set. You can also invent more data. So inventing data, what is that? So suppose like I can give an example. So Nvidia was is designing autonomous car or autonomous vehicle where it will like from a bunch of sensors and also cameras, there will be lots of 12 to 20 deep learning models. They will help the system to take the decision whether it will move forward, there are any obstacle, something like that. So they did some research and they have seen that it's not like they have only they have already 20 cars that they're using to collect data. So they are running 20,000 miles a year. So it's like 400,000 miles. So if they look at the statistics of San Francisco of accident occurrence, then they can see that every 100,000 or 400,000 or millions of miles is causing a categorical accident. There are like lots of categories. So in that way, if we do some probabilistic, then we can see that the chances of experiencing accident by those 20 cars are really low. So does it mean that those cars will have 100% accuracy? No, we will have to create more scenarios. So it's like we will have to invent more data for training. So what they have done, they put the camera, like the car, in front of a screen, and not at the car, all those sensors, and they projected the screen in a way where it was looking real, and they were it's kind of like simulation, using simulation to test the system on those kind of invented or simulated scenarios. It could be using games, or it could be using 3D models or Unity engine. So they did that. They invented their own data to test their system, or even train their system. So it's a very common trend right now in the industry, as we have like a huge shortage of data. So a lot of companies are right now inventing their own data. We can rescale our data. That's another way. So we all know, if you have any design any deep learning application, we do lots of normalization, we do rescaling, we do standardization of our data of images. So what kind of rescaling? We can sometime within the data we have 1000 samples of images. We set that we want to do random sampling of 0.25 zoom level to minus 0.25 zoom level. So it will automatically zoom the image, the samples we have, and create more samples. So from 1000, we can create like 10,000. So the same sample, but in different from different viewpoints. We can normalize the data. A lot of times, if we it's really hard if the data has lots of classification. So in that way, we sometimes convert those data into two classes. Like we can normalize them into 0 and 1. Like if it's an image, we can convert it into a binary image, or we can convert it into a grayscale image to have like a single scale to make the system more specific and useful. And also, if we have like a categorical data, suppose in one category, in one feature, we have a category data of there are like 5 categories, A, B, C, D, E. So and the data, each row is representing one of the category. So in that way, we can convert that categorical data into and apply one hot encoding, where the A, which is the first value of the category, will be represented as 00001, the E, which is the last value of the category, will be represented as 10000. So in that way, it is way easier for the system, for the deep learning application to take decisions and manage those data. We can also transform our own data. It depends what kind of transformation you can do. You will have to visualize the data. You will have to play with the data. It's like if your does a column look like a skewed Gaussian? If it yes, then you can consider adjusting the skew with the box Cox transformation. Or if the column looks like a exponential distribution, then you can always like consider a log transformation of that data, of that column data you have. If the column is looking like it has some feature or some value, then obviously you can try some squaring or square rooting of that exact column. If you have uh, like each like row has lots of columns, and if you're finding it, it will be hard to fit all the column data in your data set, or you may have overfitting or underfitting from your data. Then you can use lots of dimensional reduction algorithm PCA or LDA, or even you can use convolutions, or you can cluster your data and then feed it to deep learning. You can also do that. Transformation is also based very important. It depends your data type, and yeah, and feature selection, as I have already said, based on the feature, you can before feeding it to the system, you can convert them into different kind of apply one hot encoding to categorize them, or you can make them in a way where it will be more consumable, and the system will be more faster to design the overall ensemble from the data. So these are the top 5 feature for me if you want to improve the performance of your deep learning application using data. Get more data, use open source data sources, invent more data. Inventing means take simulated data, add it with your actual data. You can also do that. Annotate your simulated data using unsupervised algorithms like k-means, or any other kind of distribution algorithm, or convolution or algorithms. You can rescale your data. You cannot rescaling means creating more data from your existing data, normalizing them, rescaling them, standardizing them. You can transform your data based on the shape of the data, the type of the data. You can reduce the data. Still, you can keep the overall pattern of the data. So this is the overview based on the performance increase on the data. Let me know if you guys have any question regarding the data. Otherwise, I will move forward. Okay. If you guys have any question, please let me know. Would love to answer. So what are the other options? We have shared few other options, we can improve the accuracy using data. We can improve the accuracy using algorithm tuning, or other processes, or training strategies. So let's look at the improved performance with algorithms. So what can we do? First thing that we always do, whoever is working in deep learning or data science process, profession, we take lots of help from literature. So academics are doing research for years and years to invent lots of algorithms, lots of ways to feed the data, to get to boost the accuracy, to get better runtime. And they're also publishing those novel works at different journals or conferences. So what are we doing? We AI engineers or data scientists are always following those literatures and their work, and helping we're taking those theories and applying them in our application world, where to get to design a better application, or optimize our existing applications, or increase the performance or runtime. So in that way, I will always say take help from literature review before if you are designing any deep learning applications. review as many papers as you can, review the architecture, review the network, how they designed the network, what are the best practice strategies that they have taken, how they have divided the overall data, how they have op- like uh, optimize the overall network in the deep learning application. Are they using what kind of framework they're using? Follow that one as well, and any specific tips they have, or any specific option that they any specific thing that they have used to get better accuracy. So I will always suggest that everyone to do that. Resampling method, it's you need to know that's also very important thing. So it's not you will take one solution and you will apply, which algorithm to use. Yes and no. You know what kind of algorithm to use. Suppose for classification, there are lots of algorithms. So like the decision tree, take it as an example. There are decision, forestry. There are random decision trees. There are different classifiers that you can use to solve one problem. But not all the classifiers are going to give you the similar kind of result. So different classification and the algorithm strategy give us different kind of results. So for that reason, there are lots of tools right now, AutoML. You can use them to run your experiment in a bunch of algorithms at the same time and see which algorithm is giving you the least amount of loss value in the loss function. And based on the after monitoring the loss function, you can select the best algorithm for that exact data set or experiment. And also you can do lot different kind of validation to make your model robust. Like you can apply k-fold cross validation to make it to make your application more generalized, so that the result you will get will be more acceptable. Yeah, it depends. Maybe you have exploit hardware, and to improve, you can also use your hardware optimization to improve your estimation or performance. For example, if you have a cluster of services or any kind of cloud services, then you can train in models in parallelly, then take the mean and and also the standard deviation of the result to get a more robust estimation. Or yeah. And the third one is my most important, my most favorite, transfer learning. So it's transfer learning is kind of bringing a new revelation in the field of AI. So it's actually bringing the concept of artificial general intelligence instead of AI, only artificial intelligence. So what is happening in case of AGI? So just think like a human. So when we started to started to learn to ride bicycle, the knowledge of riding bicycle helped us to learn to ride a motorcycle. So it's quite same, just a bit different, because it is a motorcycle and that the other one doesn't have any motor. So so transfer learning is similar to that. So what is happening in case of transfer learning? You have, suppose your data set is very small. You have to get a result using 1,000. You have to do a classification or design a classifier using only 1,000 images. So what can you do? Are you going to use those 1,000 images to design a deep learning model from scratch? No, that will be a very bad strategy, because you'll have to train it for years and years, for a long time, not years, obviously. And also the chances of getting overfitting result is really high. So for that reason, what we do these days is we take one existing pre-trained network, like it could be VGG network, or it could be ImageNet or GoogleNet or anything. So we take that one. Suppose for VGG there are 7 layers. We take 7 layers. Those layers are already trained. It is already pre-trained network. We can freeze layers from an existing pre-trained network, and also we can retrain like those like one or two layers based on our specific data. So for any kind of like for VGGenet, what we have seen that first 5 layers are giving the similar kind of result for any kind of image data. Last 2 layers are actually domain specific. So for that reason, what we can do, we can take one VGG network, we can freeze first 5 layers, and then we can retrain last 2 layers based on our own domain specific data and use the existing learning of VGG network of first 5 layers to increase the accuracy. And like next week or a week after that, we have another webinar on artificial general intelligence or transfer learning, where I will show uh, like the differences, hands-on difference, like using like 1,000 images and designing a network from scratch is giving you suppose 50% accuracy, and using the same amount of data, but through a transfer learning approach will give you a big boost and will give you 65 to 70% accuracy. So that is huge. So you can also like go through that approach. So the top 3 approaches that we can take to improve the performance of our deep learning application are get ideas from literature, resampling models, and go with transfer learning. Let me know if you guys have any question. Otherwise, I will move forward. Okay. So the third approach to increase the performance of deep learning applications is improve performance with algorithm tuning and parameters. So that is also very important, and we all need to do like this kind of like small like tuning to get better accuracy. So one is okay, there are like a bunch of like ways we can do algorithm tuning and like and also uh, um, like parameter tuning. So the first one that I forgot to mention here is diagnostic. So we will have to visualize our result. We will have to monitor our result. It's like we'll have to see whether our result is or our overall model is giving us underfitting data or overfitting, underfitting result or overfitting result. So based on the data strategy, if is it like underfitted or overfitted, we'll have to notice it. If the training is much better than the validation set, then we are probably overfitting our network, and we will have to use techniques like regularization to get rid of that. If the training and validation are both low, then we are probably underfitting our network, and we can increase the capacity of our network and train more and longer to get rid of underfitting. If there is an inflection point when the training goes above the validation, we may be able to use early stopper. That will help us to stop the network and preserve the like best result from there. So we will have to go through those strategies. Weight initialization, that's also very common. What we can do, the rule of thumb is to initialize using small random numbers. Uh, so why small random numbers? So when we for in case of neural network, what happened if we start with 0, the initial weight, after like we will have to go through more like epoch to like set those or tune those like weight values. But if we set a like initialize weight values with like a random number, at least we are few steps ahead of 0 initialization. And also we can try all the kind of like different initialization methods. Um, like and sometimes they could be in a way where they're constant values or there's something else. We can also try pre-learning with an unsupervised method like autoencoder. So and also we can try an existing model and retraining a new input and output layer for our problem, just like transfer learning. We can use transfer learning approach to initialize our weight as well. So the second one, the third one actually is learning rate optimization. So it's also very important. So what I always do, I always start with like suppose big learning rate, and then notice it, like monitor the overall result. So we can initialize the learning rate, suppose 0.1, and then after like 200 epochs we can plot it somewhere. Then we can initialize the like change the learning rate to 0.01, then 0.001. If we have the luxury of like heavy GPUs with heavy resources, then obviously we can do that. Otherwise we have a limitation over there, but wherever we are hitting that limitation, we'll stop there. But that's a good approach to like increase the accuracy, and that's a very common approach as well. Activation function. There are like lots of activation functions in the market, like in the field, like theoretical field. We can try them. You'll have to see which one works better for your data set and also for your experiment. The common activation function for deep learning is Atom Optimizer. We can there are like lots of researchers have used MSc as well in their own research as an optimization activation function. Network topology. That's also a very interesting ways to increase the accuracy. What we can do, we can try one hidden layer with a lot of neurons. We can make the network deep. We can make the network wide. We can try different combinations of hidden layers and their number of neurons. We can try the architecture from existing like literature reviews, literature like published on that domain. And also we can change the existing architecture like a bit based on our intuition and our data and our experiment and our available resource limit as well, to see whether it is affecting the overall result performance or not. We can try different topology patterns and rules of thumb from different books and papers to design our network topology. Batches and epochs. We will have to like batches are like having an optimal number of batches is very important to in case of deep learning application designing. What I've noticed is if you like, obviously you will have to go with the mini batches. Suppose if you're designing an image application or classification using images, your batches will have to be in a size of like 32 to 64 or 128. It depends. Like obviously, if you are using a bigger window, then your batch size will have to be small because you will hit the your resource limitation. But if you're using a small window, then I would prefer like suggest you to like have a bigger batch, like 1 to 128, 64, 256 to get a better result. And also you will have to go with epochs, how many epochs you're going to run. You can implement early stopper in your within your epoch, and also store the best one. It's kind of like after 10 epoch, your loss function dropped into 0.05, and then again up like from 11 epoch, your loss function is going up. Then on that way, in that situation, you will have to store 0.05 or consider it the binary you will get as the optimal network for those for the combination that you have provided. You'll have to do lots of code optimization, obviously, to get better result. Mixed precision, you can like NVIDIA GPUs are supporting mixed precision, and also like you can go with mixed like float 62, like float 16, float 32, float 64. You have those facilities where it's not like you have like you will have to occupy the entire space of the data set by initializing your data as float 64 or something like that. No, you have the luxury to have float 16 now. So based on the data, based on the classes, you can use mixed precision and optimize your overall like network way more than you can even like imagine. Early stopper we have already talked about, and regularization for neural network, it's a very common thing, or for deep learning. So as deep learning applications are, if you are finding out your network is giving overfitted result, then you can use dropout. You can randomly drop out 50% of the network and take the decision based on the rest of the 50% of the network. And we have always noticed that dropout gives us better result than using like the whole network. So you can also try that one. So the approaches that you can take is diagnostic, monitor your overfitting and your result, whether it's overfitting or underfitting. Your weight initialization, you have to see a learning rate, optimization, selecting the best activation function, check network topology and do some fine tuning based on the topology. Select the best batches and epochs based on your resources, available resources. Use mixed precision, optimize your code as much as possible. Apply early stopping and use dropout technology. So let me know if you guys have any question. Otherwise, I will move to my like last option, and then I will give some like a rule of thumb kind of suggestions. So the last one is the fourth one is improve performance with the ensembles. So you can combine the prediction from multiple models. That's another way. Instead of like using only one model, you can use for different approaches. You can use multiple models and then combine them at the end. And the chances of getting good result is really high for using a combination of multiple models. But we can also take like there are like few approaches that you can consider for like ensembles. One is combining models, combining views, and also stacking. So the first one obviously refers to combining different models in under one pipeline. Second one is also you have trained your network with different view or different framing of your problem as you're using multiple models under the same pipeline. So you can combine all those views to get a better result. You can also stack them together. Um, uh, it's kind of like a way. The best approach is to stack your multiple models together or combine your multiple models to have like a generalized like stacked network. So I call that network of networks to have a one unified result. So yeah, suppose think about it like that. You want to design one deep learning based video analysis network where you can have one data cleaning model, one noise reduction model, one colorization model, one upsampling model, one interpolation model. All of them individual models can work together to design a one unified data cleaning or video upscaling or video processing deep learning pipeline. So you can design that software, bring that in the market, and that would be a good idea to make a lot of money because NVIDIA is currently trying to do something like that. So you guys can try that as well. Uh, the other rule of thumbs are continuous and like I will share. One is continuous and unbiased training. So sometime what happened, like continuously, if we continue to like train our network continuously, we get better result. So if the accuracy rate or if the loss function is going down, then I would obviously suggest you guys to go with that approach. But to make it unbiased, a lot of times what happened, whatever we have learned in the past, we forget them, and we just our network is always focused on the existing training data. So it is obviously biased training. You won't get the network won't be generalized, and you won't get a good result because of that. So to make it more robust, what we do split the data into like a 30-60, 30-70, 40-60, or 50-50 like ratio, where based like from all the past learning we will keep 50% of the data, and from the new learning or new set of batches we will have 50% of the data, then we will train it. So in that way we can also preserve the old learning, and also add more learning categories using the new data. So in that way, our training will be unbiased. We can train using TensorCore. It's a NVIDIA library, uh, mostly for training using mixed precision data structure, so that you can train your network way faster than the general approaches. And you can, for inferencing, once you have the trained network, you have the binary file. Now you want to do inferencing, which means you want to pass one value and want to get the prediction on the based on the existing network. So existing trained model. For inferencing, you can use TensorRT, where you won't have to do that much work. You will just use that library, and that will optimize your network by itself to give you a better result. There are like other ways. You can also go with neural network pruning, where you will find out which neurons are not taking part in decision making process. So you can prune them, but it's a time consuming and also very hectic task. So but if you follow the approaches that I have shared, your life, if you're designing a deep learning model for production, your life will be easier. Like, trust me. And let me know if you guys have any question, or you guys can comment on the video. I will try to come back to you guys and answer it. That's all from me today. Thank you.
That's
Deepak,
a
you
great
there?
session, Rahat. I really learned a lot of things for me. It's kind of more or less different world, but thanks for sharing such a wonderful things about artificial intelligence. And I know everyone, they learn it had their knowledge. And being said that, also all set with my presentation. I think you guys could see my screen, right?
Yep.
Okay, that sounds great. So let me look our chat window if we do have. So thanks much. It means session is really nice. And now let me start with. Okay, guys. Good morning. Good evening, whatever the time zone is. Uh, Myself is Deepak Kaushik, a Microsoft MVP, CSAP Corner MVP, and Saskatchewan, which is one of the province in Canada, Saskatchewan chapter lead. Azure, my subject matter expert. Being Azure subject matter expert, I contribute to the Microsoft fraternity to give the feedback of the Azure about their different products, their certifications, etc. I tweet at Think for Deepak, and deepakoshik.com is my blog. So you could contact me anytime by any medium. So today, me and Raha decided, hey, let's talk about something new things which we have learned in couple of months. So we figure out, okay, this what we could do. So Azure storage or storage is where such an important thing. Like any business can't sustain with any storage. For example, a banking system or any insurance system, how they sustain if there is no data to store. So it's irrespective of the Azure cloud platform, Amazon, or maybe on-prem. So storage is such an important thing, and we have to decide our storage strategy accordingly. So, what could be our storage strategy? Uh, we have to decide whether we need to perform our storage at the disk, maybe Azure IaaS disk, or maybe in the file shared at the cloud, where we could lift and shift by legacy application and consume it. We could store our data at Blob. Blob storage is for unstructured data. We will touch base over there. Tables for NoSQL or queues. Maybe if we have to send some message, we want them queuing. So As we could see, it's distributed under IaaS, infrastructure as a service, where storage, virtual machine, and networking are there, and some things exist into PS, platform as a services, where blob, table, queue come under the existing framework, microservice, etc. But being said that, let me tell one thing: these lines are blurred now. As soon as we are moving towards more Azure or more cloud maturity, the lines between IaaS, PS, SAS are blurred. It's not the same lines which we have, learned and working in last couple of months or years. It has been constantly stress to change that. It is the same like public and private cloud. Maybe after a couple of years, we don't find anyone private cloud. Everyone will be on public cloud. So we have those kind of Azure services, but today we are focusing on blob storage, queue storage, file, and disk. We will look for what storage exactly mean. If your business what your business required. If you are working as software engineer, you may go to your project manager. Hey, I feel for this requirement blob storage is the good thing. For example, I'm working with the public sector of the Saskatchewan. Saskatchewan is my province. And For that, for ministry data and couple of things, I said, okay, why don't we use Azure? uh, Definitely couple of questions raised about security and concerns. If you want to have answer for those questions, then stay tuned for our next session, which is happening next week. But currently zero down to the storage, I said, okay, these are the benefit of this storage. We could use, for example, videos or training for the kids, for the blob storage. And you could do that thing. There are many another question which you may be asking, okay, why not I could store everything into the SQL? Why I need storage, and what the heck I have to use with the blob storage or the file storage or queue storage? So there are many reasons and approaches. Owing to that, you could choose which tool you need to pick up, and it depends on majority of the factors. And couple of factors are, okay, you need unstructured data, use blob storage. You need structured data, use SQL, Azure SQL. You need Azure semi-structured data, maybe JSON file, use this kind of storage. You have different properties of data, like how many data you want to store, what frequency you required. For example, for my business, my volume is too high, but velocity is not as much higher. For example, I'm not into the banking domain, I'm not into the insurance domain where I have to keep tracking of everything. No, that's not the reason. We have to look at the variety. We have various example where we could say, hey, semi-structured data we need to store. What should be the latency, high, low, or intermediate? What if I need to store unstructured data, for example, videos or pictures or files, or logging file, for example, traffic logging files or sale data, etc. You have a bunch of regions to figure out. So how we have to match data for the storage? We have to figure out first and foremost what storage we need, what option we could use. There are APIs available, there are security options available, there are function available. What we can use to make more sense to my business? We want to ensure whatever we are using, we get full quality of that strategy. And that is what Microsoft Data Story itself. We have data, we are ingesting data now, not only with the application from mobile app, from various app, third party apps, SQL Server, etc. We could store data into the Azure's files, backup, migrate. Then we could use ETL process, Azure Data Factory. If we had one last session with one of the folk from Toronto. He is such a Azure Data Factory enthusiast. So if you don't use that, probably I will keep posted. So for ETL process, we have data. Say data, you have data. If you want to publish your data, extract, transform, and massage your data, what you will use, you have various options like data factory, data catalog, event hub. Then you store data into the data storage, maybe data lake storage, Azure SQL DB, Cosmo DB, Azure SQL, or Azure SQL Data Warehouse, which is one of the demo we are going to do today. And then we have machine learning, which part is well taken care by Rahat, talking about, okay, these things, have to be used so that we could get the benefit of our data. Like data sitting at the corner is of no use, right? So we need some cognitive services, maybe chat framework, maybe bot framework, or something, so that you have learning and analysis. And furthermore, you could have Power BI or SSRS, whatever the visualization to look over that. So being said that, let me show you demo for the blob storage. Please let me know if you could see the screen. Okay. So this is my blob storage. This is my portal, and I'm using my personal portal. If I use uh, blob storage over there, and I say, hey, I need to store, data in blob storage. So because of security reason, you could not see my screen various thing, but yeah, I faded them. So I could go to storage account and I could say, okay, I need blob storage. Uh, I would say, okay, here you go. What type of storage account you want to create? I would say, okay, I want to create blob storage. I would like to use Azure sponsorship. Which resource group you want to use? I would say demo, because it's the demo storage account name. Today, C sharp corner demo Saskatoon, is that available? Yes, it's saying it's available. That's cool. Well, location, which location you want to choose? As I'm from Canada Central, I will choose Canada Central. And account type, review and create. What replication you want to procure for this? Do you want it locally available, or I would say, wait a minute, no, I don't need it locally. I need it geo-redundant storage, or read access geo-redundant storage. So choose as per your business requirement. Access type, cool or hot. You need it always available, very very fast or very cool, kind of that. And once you do create storage account, you could hit on the create button. As soon as you hit on the create button, it will take a couple of seconds, or at most a minute, to procure your storage account. And as you see, the storage is now available. It Now you have this storage available, and you could go to all resources and you could find the storage. As soon as you will find the storage, you are all set to look over, different thing. Like this is my storage account for demo for Summit. I think I did it for Seattle or Toronto, something like that. But this is the storage account. You could say, hey, I need blob storage. Okay, you are all set. But what blob storage is used for? Blob storage is used for image. So I would say Saskatoon storage. Maybe it would say complaining about, hey, use small words Saskatoon storage. I would say, okay, make it private. I would say, that's right. I made it private, no problem. I have now container available. Container is like folder, right? Once we have container available, we could upload anything. If it is the blob storage, we could upload image, or we could upload, maybe this is how about this image? I don't see anything good image, but I choose this and say okay, upload it. As soon as I did that, it will upload the image is available, you could access it. So in your application, if you are a developer, from developer perspective, you have a unique URL where you could copy and access that image. So that's the benefit of uh, uh, blob storage. You could have your storage available. You could say okay, you could edit blob storage here, you could see, you could download it, or you could see the snapshot. So you have a lot of options available. So that's the benefit of blob storage. And once you are done with the blob storage, let's jump into the another storage type. Over here, I will say, okay, create a new resource. And new resource type is the Azure SQL data warehouse. Maybe SQL data warehouse. Here, that is another storage type. If the guys who don't know, who or did not get the opportunity to work on, well, what the Azure SQL data warehouse is a common place where you keep your historical data from different isolated applications so that you could analysis report on them and keep the data. It is not OLAP data, transactional data, but it is the analytical data. So you keep it. And why we are using SQL data warehouse, there are many reasons. For example, it has massive parallel processing. You don't need in front a lot of amount. For example, if any one of you have to procure a data warehouse, uh, on-prem data warehouse to be precise, then probably it will take thousands and thousands of dollars, right? You need to investment, you have to procure hardware, software, networking, internet, etc., uh, security, and some resources. But if same thing you have to do, you could do from your Azure portal. You could click on the create button. As soon as you will click on the create button, it will ask, hey, what is the your name, data warehouse name, and I will say okay, it is the demo Azure data warehouse. So it say okay, available, what next? I would say okay, use the subscription of Azure sponsorship. And then what type of data you want to use? Would you like to back up something maybe on prem? I would say yes, and then it will ask the configuration. Or you will say okay, do you need sample data, maybe the adventure works data? I would say no, but I would like to have blank database for my demo purpose. So you could have any type of data which you required as per your business requirement. And you could select okay, what data warehousing unit you need. Data warehousing units are kind of units to measure the performance of your application or data warehouse. For example, car performance is measured in horsepower, right? So similarly, if we have to measure the performance of data warehouse, you could choose data warehousing unit, and it may be from Azure data warehousing unit 100 to 200, 300. The beautiful thing is you could see the cost right on the another corner. Let me increase the font as well. If you guys, right, you could see the font as well. You could see the cost as well, how much it's going to cost per hour or per day. And once you could scale it up and scale it down, it's such a wonderful thing, right? You could do you could do it that, and you could say okay, that's what I need. Now apply. As soon as you hit on the button create, then you are all set, and it will create your data warehouse. Once your data warehouse is created, then what next? As we said, once your data warehouse is created, for example, demo for Toronto, maybe I'm taking this example, or let's see if my data warehouse has been procured. Usually it doesn't take such a long time. And yeah, seems we are all set. Let me look. Demo for Toronto. This is the data warehouse. So what next? What we need to do? We have data warehouse, right? You could do couple of things. You could purge it, which you can do on your on-prem data warehouse. You could purge it and use it whenever you required. You could write the PowerShell command, and you could do a lot of bunch of activities. As we look over, you could scale it up, scale it down. Being scale it up means you could increase the power of the Azure data warehouse to 100, 200 data warehousing unit, or 400, whatever you required. So we are over there. You could say, okay, this is my data warehouse, and we could restore it, we could use it. Then activity log, and you could load data, which is very important. If you have data warehouse without any data, what does it mean? You have various options available. You have Informatica cloud services. Honestly, I didn't use that. I use data platform studio, where I copy the data on-prem to cloud. I'm using Azure Data Factory. This is such a wonderful thing on version 2. Uh, Azure Data Factory is such a good thing. If you want your ETL operations to be executed, you could use the Data Factory, Azure Data Factory thing. It's such a great thing, right? And we already look, you could query it from here, or you could use it. So you could directly query your database from the same place. You could open it in Visual Studio. So I expect majority of us are from development background. So if you are also a developer, then seems this is what we required. And you know, we could use it to the Visual Studio. So these are the various things we could play around with the data warehousing and different stuff. And once you have your storage available on the blob storage or data warehouse, or maybe like this SQL data warehouse, then you are all set. So being said that, let me go over here. We did the blob storage demo, and then we did, let me run my screen. We did demo for Azure data warehouse. So we look over various things about data portal. I don't want to make it a screen compliances, or more or less the PPT type presentation. So but we look over, okay, this is our demo for Saskatoon today, which we created. This is the C# corner demo for Saskatoon. We could open this storage in the Explorer. We have Explorer, and we could open it, and we could use it. Being said that, that's what we could do on data warehouse thing or storage things. If you guys have any questions, you guys could ask the questions. Otherwise, I think I'm all set with my Azure storage presentation.